This is Physics 2, Lab 2, Charge Tape Revisited. My name is Joshua Smith. Introduction. This lab is designed to give students a feel for the magnitude of excess charge that an object can have. The purpose of this lab is to use class knowledge and previous experimental data to determine the amount of excess charge on the tape using a more sophisticated model. Preview, the total charge of the tape is going to be greater than our estimate in Lab 1 due to the use of a line charge model in place of a point charge model. The system and surroundings, the system is the top tape and the surroundings is the bottom tape, and everything else like the meter stick, hands, erasers that we use to hold up the tape, all of that. Some fundamental physics principles is Coulomb's law to calculate the electric force, Faraday's electric field to calculate the electric field, Faraday's electric force to establish a relationship between the previous two measurements, force and electric field. And force of gravity is important so we can establish what our net electric force is going to be equal to. And then something new in Lab 2 is electric field for a finite line of charge. This formula is derived from some more complicated stuff using infinitesimal bits of electric field and bits of charge, but this is the end result, and this is like a visualization of that. The experiment, I'm not going to go into too much detail because it's the same as Lab 1, but we charge the tape and hold it up to another piece of charge tape and observe the relationship, the interaction. Initial conditions, also the same as Lab 1, but the ones in bold are the most important measurements, that initial conditions that we're going to be using. Calculations, so we set our, so the net force is going to be adding the net electric force plus the force of gravity, and we end up getting our net electric force equal to the force of gravity. And then we use the formula for a finite line of charge to find Q. And what we get Q to be is this number right here, which we'll talk more about later. This is like a rough visualization of the infinitesimal charges and electric fields. Our computational model, we have our physical constants and some of our initial conditions that we put into the code. Then our electric field function that we used in Lab 0. And then this function makes the lines that our point charges are going to go along. These represent kind of the axes that the tapes are on. And then top tape and bottom tape are created. And then these scales are to get the sizing of our arrows reasonable. And then these for loops go along these tapes, and for each point charge along the tape, they're calculating this electric field, and that's how we get this model right here. And then our magnitude of electric force and gravitational force are equal to each other, but I will note that in the last slide, or actually in this slide, our model charge is different from the charge with our formula, and I believe the difference in the charge calculated by the model and the charge calculated using physics principles can be attributed to the model's use of n number of VQs instead of an integral that we used that is derived from the formula we use. Only 10-point charges are used in the model, whereas the formula is derived using an integral, accounting for all DQs in the line. Following this reasoning, I believe the increasing value of n in the model would lead to more accurate charge calculation closer to the value calculated using the formula. Some assumptions are same as last time. The big one here is treating the long tape as if it were a line charge instead of like a surface charge. Some possible sources of error, similar things as Lab 1, charge tape is not a line charge, but we assumed it was even when the distance between the tapes was quite small. In reality, the charge is distributed over a surface area, so that could cause some issues. Then some of these questions is going over the difference between our point charge model Q and our line charge model Q. And as you can see, the point charge model Q is lower than the Qs that we calculated using our new model. And these estimates differ differ because of how a charge is distributed has a significant effect on net electric field and net electric force. When an electric field originates at a singular point charge, its effect is exaggerated. On the other hand, when an electric field is generated by distributed charge, a more careful calculation can be done with more respect given to the different electric field vectors. And I think this one is the most accurate as it is using integration.